Hello friends, my name is Dr. Sunil Kumar Jatov. Today I am going to discuss about the we are going to here solve some problems on the based on the law of comminutions. So you are welcome the channel Meta Engineering. So what is the problems? Here is given the problem is given here. Problem is given. The particles of the average feed size is the 50 mm. 50 mm. So what is the solution of this? So here dp, this is the feed size. So feed size we can written as the df. Df is given 50 into 10 to power minus 4 meter. He said, are the crust to the average product size is the 10 into 10 to power minus 4. So what is the dp? dp is 10 into 10 to power minus 4 meter at the rate of 20 tons per hour. So capital M is the 20 tons per hour. At this rate, the crusher consume the 40 kilowatt of the power, and out of which the 5 kilowatt are required for running the mills empty. So what is the actual power consumption? So uh, actual power consumption actual power consumption. So the total power consumption, how much? Total power consumption is the 40 kilowatt, and required for the run the empty mill is the 5 kilowatt 5 kilowatt. So actual power consumption is the 35 kilowatt. So this is occur in the first case. Case first. In this first case, these data is given. So how can calculate this? So you know what is here we can apply the Rittinger's law. So he said the calculate the power consumption if the 12 tons per hour of the product is further crushed to 5 into 10 to power 4 meter size in the same mill. So mill is the same, and this product size is further crushed than the for the second case. the these data are the as the feed size, and this is the product size. So in the first case we have to calculate the Rittinger's constants. So according to Rittinger's law, here Rittinger's law can be applied. So what is the law? E is equal to P by M KR dphi minus df. So put the value here. P, you have given the P 35 kilowatt, M is the given the 20, and KR we have to calculate, and this is also given 10 into minus 10 to power minus 4 minus 50 into 10 to power minus 4. So further we solve this and now we can get you can get as this is the solve. The 35 divided by the 20 is the 1.75, 1.75, and this all is the calculated, and here you find the kr thousands minus 200 equal to kr is equal kr into 8,000, 8,000. This is the 175. So kr is calculated, kr is calculated approx kr is calculated 2.1875 into 10 to power minus 3 kilowatt hours per meter by per ton, kilowatt hours meters per tons is found. So in the second case, it said that in the second case it said calculate the power consumptions if m is, so it is we have to calculate the power consumption if m is equal to 12 tons per hour and the particle size is further reduced, means from the 10 to power minus 4 meter to 4 meter to 5 into 10 to power minus 4 meters. So this is the, for the second case, this is the feet size in the second case, and this is as the dp feet size, and machine is same, then kr is the same, so 2.1875 meter per ton. Okay, we can rewrite in the equations. So p is should be the calculator, m is given 12, kr 2.175 into 10 to power minus 3, this is into 10 to power minus 3, and dp is 5 into 10 to power minus 4, that is given this, and df 10 into 10 to power minus 4, and calculate this, and after the calculations p is equal to 2.1875 into 10 to power minus 3 into 12 into 200 minus 1000. So after calculating this, you can get approx 26 to 5 kW per hour. This is your answer. So thank you. Hopefully you will like this, and you have any doubt, you can write in the comment box. Thank you.